Hi, we will now be discussing beta decay. In beta decay, a neutron must decay into a proton and an electron. An additional particle with no charge and virtually no mass must also be emitted. This particle is called an antineutrino, and it is written as like this. The proton remains in the nucleus and increases the atomic number by 1. Carbon 14 is a radioactive and eventually undergoes beta decay. This process, and in any beta decay, the atomic number increases by 1 because a proton has taken the place of the neutron that decayed. Now, let us complete the equation for each of the following beta decay. Example number 1 and example number 2. We can use both the mass numbers and charges given to determine the missing particles in the equation, much as in the previous example for alpha decay. Starting with thorium 234. The fact that both thorium and protactinium have mass numbers of 234 indicates that the other particle in the equation must have a mass number of 0. This is consistent with the beta decay. Balancing the charges on the reactant and the product sides requires that the unknown has a charge of -1, so that 91 minus 1 is 90. Because this is beta decay, an antineutrino is also emitted. The equation is now next. Turn to the decay of protactinium 234. Because the beta particle given as a product has no mass number, we know that the unknown particle has a mass of 234. The beta particle has a charge of -1, so that the unknown particle must have an atomic number of 92. The missing particle is uranium 234. So the equation would be uranium 234 with a charge of 92. Let us check your understanding. Suppose you observe beta decay and then determine that the product nuclide is 80-218. Question: what was the reactant nuclide? Thank you, and I'll see you then. Bye bye.